All right, hope everybody's having a great day today. We're going to take a look at section 1.4 where we measure and classify angles, and then section 1.5 where we describe angle pair relationships. Now, let's go ahead and get started. One of the first things that we want to do is we've got to learn how to name an angle. When you go to name an angle, you're going to take a look at one particular spot in particular, and that's the vertex. In this case, the vertex is located at point A. Point A is our vertex, and we're going to use that to help us with our angle names. Now, there are two sides. One of those sides is ray AB, while the other side is ray AC. So those are our two sides, rays AB and AC. Naming the angle can be a little bit tricky. You can name this particular angle three different ways. One of those ways is to start at point C. Now, if you start at point C, the name of this angle is going to be angle CAB. Now, a second way that you can name this angle, if you start at point B, you could call this angle BAC. Now, the third way to name this angle, we could simply just call it angle A. Now, let's take a look at example 1. It says, name three different angles in the diagram. One of them is angle HGI. Now you could name that another way and call that same angle, angle IGH. Now the second angle, we could call that angle IGJ, or we could call it angle JGI. Either one of those ways of pronouncing that angle would represent the same location. For our third and final angle, we could call that angle HGJ, or we could call it angle JGH. Now, error alert here on this one. Sometimes people would incorrectly say, oh, that's angle G. To say that that's angle G is incorrect, because I'm not sure which one of those three angles you're referring to. So when you have a diagram like this, and in all cases, it's better to use three letters to describe the angle. Now next we're going to move on to classifying angles. There are four types of names that are associated with classifying angles. The first one is acute. An acute angle is more than 0 degrees and less than 90 degrees. Here's a picture of an acute angle. Now our second type of name that we could use to classify an angle is a right angle. And a right angle is exactly 90 degrees. Now notice in the sketch that there's a little red box in the corner. That box, if you see that in a diagram, means that the angle is 90 degrees. Now I want to draw your attention to the two diagrams at the bottom of the screen. The diagram on the left, you cannot assume that that angle is 90 degrees. Even though it looks like it is, you can't assume that it is. However, the diagram on the right is a 90 degree angle, and we know that because of the box that is in the corner. Let's take a look at our third type of angle. So an obtuse angle is between 90 and 180, and you can see the sketch of it drawn on the video. Now our fourth and final type of angle classification is a straight angle. And a straight angle is just what it sounds like. It's a line, it's 180 degrees. Now sometimes that line might be horizontal, it might be vertical, or it could be slanted. In any event, your picture will show a straight line. Alright, now let's take a look at the angle addition postulate. The angle addition postulate says if P is in the interior of angle RST, then the measure of angle RSP plus the measure of angle RPST is equal to the measure of angle RST. This is very, very straightforward, and it's going to seem very similar to the segment addition postulate. So, let's take a look at example number 2. Given that the measure of angle CDE is 140 degrees, find the measure of angle CDF and the measure of angle FDE. First thing you always want to do is mark your diagram. So we're going to mark our diagram with the 140 degrees for angle CDE. Since those two angles have a sum of 140 degrees, I'm simply going to write an equation that's going to set those two angles equal to 140 degrees and solve that equation. If you understand how to write an equation at this point, using all the correct notation, go ahead and hit pause, complete filling out all of the steps, solve for x. So this is what your equation would look like. Measure of angle CDF plus measure of angle FDE equals the measure of angle CDE. Be sure to write down that first line. Now the second line is going to be where we go ahead and just substitute. So we're going to take 4x minus 8 and substitute that for the measure of angle CDF and 5x plus 13 is going to be substituted for the measure of angle FDE. 140 gets substituted for the measure of angle CDE. On our third line, we're just going to combine like terms. We get 9x plus 5 equals 140. Using the subtraction property of equality, we get 9x equals 135. And last, using the division property of equality, we end up with x equals 15. Common error alert, most people think they're done because they got a value for x. Sorry to say, you're not. Reread the question and make sure that you find whatever it is that you're asked to find, which in this case are the measures of angle CDF and FDE. So to find each one of those angles, we're simply going to plug the value of 15 that we got for x in for each one of those angles. By now, you should be understanding how to write the equation to find the value of an angle. If you think you got it, go ahead and hit pause and then come back and see if you're right. First, we're going to find the measure of angle CDF, which is represented by the expression 4x minus 8. Substituting the value of 15 in for x and performing our arithmetic, we end up with the measure of angle CDF being 52 degrees. Now we'll use a similar process to find the value of angle FDE by simply substituting 5x plus 13 for that angle, substituting 15 in for x, performing our arithmetic, and coming up with 88 degrees. Now, two errors here you've got to make sure that you pay attention to. One, notice angle CDF and angle FDE have a value of 88 degrees and 52 degrees, but with those, what you're going to want to make sure that you have on each one of those is the angle symbol, because the measures of those angles are in degrees. Notice on x equals 15, we don't have a degree symbol. 15 only represents the value of x. It does not represent an angle. So that's why we don't put an angle symbol after the number 15. Here's the second error alert. Add the two values that you got for each one of your angles. They should have a sum of 140. If they don't, we messed up somewhere. So we're either going to have to go back and make sure that we solved for x correctly, or if we did find x correctly, then it's probably in our arithmetic. Make sure that you copy the angle down correctly, you didn't mess up a plus sign or a minus sign, and that you actually plugged the correct value in and did your arithmetic correctly. Those are the two common errors: forgetting to put your degree symbols in the right places, and then also making sure your angles add up to 140 degrees. Now the last piece for this small video is talking about the angle bisector. An angle bisector is a ray that divides an angle into two congruent angles. That's just what it sounds like. It'll take an angle and just chop it in half. Let's take a look at our first example here. Example number 3. In the diagram, ray SP bisects angle RST, and the measure of angle RSP is 19 degrees. Find the measure of angle RST. Let's take a look at what we have to find first. Measure of angle RST. So we've got to find the measure of angle RST, which is the entire angle. The other piece of information that we're given is the measure of angle RSP is equal to 19. So we're going to go ahead and mark that in our diagram. Now, the third piece of information that we're given is that ray SP bisects angle RST, so that means this angle and this angle are going to be identical. So we know that one of them is 19, so that means the other one has to be 19 also. Both angles are 19 degrees. Now we're asked to find the entire angle, angle RST, so that is simply just going to be done by adding those two angles together. So the measure of angle RST is just going to be 38.